know that this is the adsorption capacity at equilibrium, Qt is adsorption capacity at time, K1 is the pseudo first order kinetic constant, and T is time. We will plot ln QE minus Qt versus T. Our T will be on x-axis, while our y-axis values will be ln QE minus Qt. And from this we will calculate the QE and Qt value and K1 value from this equation by plotting these from the slope and intercept. So let's begin. As you know that the equation for calculating QE is C naught minus CE divided by W multiplied by volume. As our volume was 60 ml, so in liter it will be 0.06. Just dividing 60 over 1000, we will get 0.06. And the same, our W, our mass of the adsorbent, was 60. So it will also be equal to 0.06. 60 divided by 1000. Okay. So this is our V and this is our W value. So QE will be equal to C naught minus CT multiplied by volume 0.06 divided by 0.06. Okay, and copy this formula. Copy the formula till the end. So now we have QE value. Okay, the next thing is when you are doing the kinetic modeling, you have to choose one initial concentration, as these are different initial concentrations, and for every concentration we have QE value. So in our experiment we use 30 milligram per liter for the optimization. For the optimization we only used 30 milligram per liter. So this data we will use in determining the pseudo first order kinetic model. So we run an experiment with different time interval. We know our initial concentration is 30 milligram or 30 ppm, and then we calculated the concentration at time, at 0 minute, at 10 minutes, up to 120 minutes. So this is our CT value, concentration at time. QT we will calculate from this data, C naught minus CT. The formula will be the same. This one, the equation will be, we will have the same equation. QE is equal to C naught minus CT. Instead of CE, concentration and equilibrium, we will have concentration at time multiplied by volume divided by weight. So we'll have the same formula is equal to C naught minus CT multiplied by 0.06 divided by 0.06. These values can be different as according to your volume and mass of the adsorbent. So we will drag this till the last concentration, and this is our QT value. QE value for 30 minutes is 19.238. So we will copy this and paste over here. Drag it till the end. Now QE minus QT. QE minus QT, and copy this till the end. Next is ln QE minus QT is equal to ln natural log of this value, and copy it till the end. So we have ln QE minus QT value, and we have time value. So we will plot this value against the time. Against the time. So let's copy this and plot it in origin. You can plot it over here in Excel or in origin as you wish, but I prefer to plot these values in origin. Take the scatter plot and then go to analysis, fitting, linear fit, and open dialog. After opening dialog, no need to change anything, just press OK. Press OK, and then OK. So this gives us the intercept and slope value. We will copy these values and paste it we'll copy these values and we will paste it over here. We have the intercept. Intercept is 3.336, while slope is minus 0.02709. Okay, now we will calculate the QE value from here. This is the QE experimental. This one QE we calculated is the experimental adsorption capacity at equilibrium, and this one is our calculated one. So we have the formula that intercept is equal to ln QE, natural logarithm of QE. When we convert this, we'll get QE will be equal to anti-ln or exponent of the intercept. So the formula will be is equal to, just write exp, you get the exponent of the intercept. Select the intercept value and press enter. So this is your calculated QE value, the calculated one. This is the calculated QE value, and this is the experimental, which you get it from the experiment. Okay, when you did the experiment, this is your experimental, and this is your theoretical, or this is your calculated QE value. Now we will calculate the K1. The equation is slope is equal to, for calculating K, slope is equal to K1 into T, while our K1 value or the K value or the pseudo first order kinetic constant is equal to slope divided by time. So we have the slope value, and the time which we will use is if we run the experiment for 60 minutes, then we will select 60. But as we are running the experiment up to 120 minutes, so we will select the 121. Whatever the duration of your experiment is, the end point that time. So it is 120 minutes. For example, if you are running it at 180 minutes, then you will select the 180 minute. If you are doing it for 24 hours, then you will go for 1440 minutes. So as the time is in minutes, so we will select that one. So 120 minutes, and this will be our K1 value. The R square value, we'll get it from here, the adjusted R square 0.84307. So our R square value is 0.84307. Okay, this is our R square value. So this is all about how to plot your data in pseudo first order. You will select only one kinetic model, that is pseudo first order. So second order, first order, second order, or zero order. So it will be based on your R square value. Any model which have more closer R square value than your adsorption, your reaction is following that kinetic model, that order of reaction. Okay, that order of reaction, it will be based on your R square value. So after this, we will do the pseudo first order, pseudo second order, and second order reaction. So we'll use the same data. We'll use the same data, and we will determine that our adsorption experiment is following which one order of reaction. Okay. So for this, let's go to the graph. You can add text pseudo first order kinetic model. Okay. Pseudo first order kinetic model. You can bold this size, increase its size, and increase its size also. You can increase the size also. So your graph may look better. As time is in minutes, so we'll go to our book and we'll write down its unit. So this may be updated over here. Okay, you can change this thing, just increase. You have the regression y is equal to mx plus c, y is equal to a plus bx. You have the slope value, and the R value is 0.8437. You can keep this, or you can write over here the square value. It depends on you, what you want. Then copy this as a picture and come to the word. So first order kinetic model, figure 1. So the first order kinetic model of whatever your adsorbent is. For example, we have active carbon. This is caption. Just paste your graph, but it will look like this one. Okay. Next is copying the table. Just paste the table over here. Okay. You can make this. You can make changes in this. And okay, one more thing. This QE is the calculated. You can also add another column and QE experimental. You can add the QE experimental value, which is 19.238, and fit it according to the contents. So this is the graph which you will use for reporting your data. Okay, hopefully you understand how to do the pseudo-first order kinetic model of your data in pseudo-first order kinetic model. This is the equation. Okay, this is the equation, and you will plot log QE minus QT versus time. You will calculate the log QE for your experimental data, and then you will get the log QE minus QT value for equation. Plot it, plot values. Okay, plot these values in equation or in Excel. I'm doing it in Excel also. We'll do the linear trend line option, display and display the R square value. So it's almost same. Intercept is 3.37, while the slope is minus. The intercept is over here 3.33, while your slope is 0.027. Okay, you can use this data, or you can use the data from the equation. I hope you understand this, and now you can do you can manage your part according to this. Thank you very much. If you have any question, ask in the comment section, and if you need any help in analyzing your data, you can consult me in the comment section. Hopefully, you subscribe to my channel, press the bell icon, and share it with other students and colleagues. Thank you, and Allah Hafiz. Bismillahirrahmanirrahim. Hello and welcome to Adsorption Science Academy. Today we will learn about first order kinetic model. What is first order kinetic model? How to plot data into first order kinetic model. Basically, the first order kinetic model is the in which rate reaction is proportional to the concentration of the reactants. Okay, the rate of reaction is proportional to the if there are more reactants, if there are concentration of the reactants at the end, then there will be the reaction will be here. If there are more concentrate, if there is the concentration of the reactant is more, the reaction will be here. And if the concentration of the reactant is less, then the reaction will also be decreased. So the rate of reaction is dependent on the concentration of the reactants. Okay, so this is the practical expression of the first order kinetic model. Log C is equal to minus 80 log C naught. So from this equation, we will calculate the K value and log C naught value, or the initial concentration, we can calculate the initial concentration of this. We plot our plot will be log CT versus time, log CT versus time. As we have the C value, we can calculate is equal to log CT value. So then CT is equal to natural log of the CT value. Okay, copy this data, copy this formula to the end, and you will get the log CT value. Copy this data and paste it over here, and then we will plot this data into equation. As I try to mention, calculating the plotting data. Okay, we make a scatter plot. Scatter log is we go to analysis, setting, linear fit, and then we open the dialog box. In the dialog box of the linear fit, just click on OK. In the next dialog box, click OK. We got the intercept value and we got the slope value. So copy these values and paste it over here. So we have the intercept value and we have the slope value. As you know that slope is equal to minus k. From here you can see that slope is equal to minus k. So k value will be equal to k value is equal to minus multiplied by this value. Our inverse is equal to log C naught. As from this formula, you can see that this is actually y equal to mx plus c. Our m is absorbed and c is the intercept. So our intercept is log C naught. Okay, our intercept is equal to log C naught, and the value of C naught will be equal to anti-ln of the intercept. So for anti-ln of the intercept, this C naught value. So is equal to x of the intercept. So this will give us the real concentration. So our initial concentration is 30 ppm reaction. So it's almost 20.5 ppm. So our initial concentration. So this confirms that our data is following the first order reaction. So yes, both are almost same. Now in first order reaction, we also have the half value. The half life is the amount of time it takes for half the initial reaction concentration to consume or convert into products. So it is important in or in the pharmaceutical industry or in medical industry. So from the half value 0.63 divided by K. So we can calculate half equal to 0.69 divided by the K value. So this is 86 minutes is equal to 5. Okay. Hopefully you understand how to calculate the kinetic model, how to calculate the order of reaction, reaction K, and how to calculate the half-life of reaction. So R square value basically is 0.98. 0.98. This is our R square value. Calculate the first order reaction, so first order reaction and first order reaction. So over here you can see that the first order reaction R square value is the value is higher as the PFOM is so moderate. So we can say till now our model is following the first order reaction. Okay, our model is following first order reaction with half time of 86 minutes. 86 minutes. Okay, so our value is high for first order. So we can say that our data is following the reaction kinetics, the first order on the reactor. If you understand how to put this data, hello and welcome to my channel, Adsorption Science Academy. Today we learn about setting data into second order kinetic model. Before this, we did data fit for pseudo kinetic model. You watch over here. The same data we use to fit into pseudo second order
kinetic model. Before going to fit the data into pseudo second order kinetic model or PSO model, you should know the information of the equation and the plot. So we have the equation PSO or pseudo second order equation Q over Q E is equal to 1 over K2 to E squared plus 1 over 2E. QE, as you already know, that this is the absorption capacity equilibrium. We will calculate the QE experiment and QE calculated by K2 or K is basically the pseudo second order kinetic constant, or PSO constant. Okay. The plot between T versus T over QE, time versus time over capacity at time. So we calculate T over QE from the equation. The experimental QE already our previous formula for calculating QE already know is equal to C naught minus C divided by W multiplied by the denominator which we used was 0.06 and same as it. Okay, so you calculate QE is equal to C naught initial concentration minus C multiplied by volume divided by weight. So we have this data. Drag this, log this one, so get the data. In our previous lecture, we logged the volume and the values, and in this lecture you can see that I dragged it. I wrote the values of W and V to over here. Now we will use 30 ppm. We will use 3 kg per liter as our base concentration. 30 milligram per liter. You can use your concentration which you are using optimization. For example, 50 milligram per liter or 40 or 60 or 100, whatever your concentration is. So we use 3 milligram per liter. We did the experiment for the 30 milligram per liter. Time experiment 30 milligram per liter. So we will use this concentration. Okay. Then in our experiment, we did experiment for time of 20 minutes for the initial concentration of 30 milligram per liter. Okay, and this concentration, the CD value we already know P425 was 0. Okay. This is our CD value of minutes. UT, you already know, we already explained in the lecture how to calculate UT. If you don't know, just convert or my video, I will explain this there. Okay, so it will be C naught minus C multiplied by 0.0 multiplied by volume divided by mass 0.06. This is our T value, and this value will be and now calculate T or QT. T is this time, T is this time, QT is this time. So formula will be equal to T divided by QT. Okay, the same formula we will copy this, copy the same formula till the end. So we got the we have the time for T value and have the UT value. So plot is I already explained. Plot will be T is T over QT. So we have T over QT value from here. T over QT value we will put and paste over here. So these two values, these two columns we use to plot in the equation. Will make plot time value from plot. We will build the slope value and the value, and this value we will calculate Q and A value. So from the scatter plot we will go to analysis and go to fitting, and in this we will go for linear fitting and open by box. Do not change any input here. Just press OK, and then press OK. So here we got intercept value and this value. Okay, the intercept and slope values. Copy these values. The intercept value, so we paste it over here. The intercept value and the slope value. Okay. Now we have the formula. Intercept is before going to the intercept. Let's first calculate QE, because in the intercept formula we are getting QE. So the slope is equal to 1 over QE. The slope is equal to 1 QE, and now QE will be equal to 1. So this QE is the calculated one. We calculated one. So QE will be 1 divided by slope. So this is our QE value. The accuracy at equilibrium, the calculated accuracy at equilibrium. As next is the intercept value. Time depth is basically equal to 1 over KQE square. Okay, and our K2 will be or K will be 2 over intercept multiplied by QE square. So first we have calculated QE square is equal to this multiplied by this. So this will give us QE square. So K2 is equal to, or K2 is equal to 1 divided by 1 divided by intercept multiplied by QE square. So this is our K value. The R square value for this we get from here. That is R square value. Copy this value 0.60. Copy this value and 0 here. So our R square value is 0.67. The R square value for the first order reaction was in our previous lecture 0.84. And R square value over here is 0.6. So it means that the pseudo first order reaction is more closer to 1. The R square value is more closer to 1 as compared to the pseudo second reaction. So we can say that our system is following or our adsorption reaction is solving pseudo-first order reaction, solving the pseudo-first order reaction or pseudo-first order adsorption. Okay. Now for recording area, let's go to the graph. Let's go to the graph. If you want this, to keep this value, you can keep value, increase its size, increase the size of this also. If you want to change the type of your symbols, you can change otherwise in this size. It's okay. Then you can add text pseudo second order kinetics kinetic model. Okay. You can give this as you wish. You can increase the size of this also. As time is limited, time in the graph and paste in order. Then click one pseudo second order kinetic model. Okay. And you can pseudo second order kinetic model. So the table table and page over here. So this is your key. This is great. And you already give your third BPM construction. You know how to so and then square and this is upscale. Select the wisdom solving which are again. Therefore, so yes, has already you can say that system of that system is faster again. Okay. Thank you very much. Forget to like and share the video. Used to display for heterogeneous study the surfaces is the form of this equation is qt is equal to 1 over beta ln alpha beta plus 1 over beta ln t. This is simple linear equation. Beta is 1 so from this we will get the value of beta. Also will be 1 beta while our intercept is 1 beta ln alpha beta. This will be our intercept. The x value ln t shall be plotted against qt value. Qt is reduction capacity at time. I have calculated the reduction capacity at time in my previous videos where I calculated the PF4 model. In PF4 model I calculated qt and qe. The formula for calculating qt is equal to c naught minus ct multiplied by volume divided by mass or w. So this is our qt value. You can go to my previous video which I made on pseudo first order kinetic model and I have explained this in detail. Over here I will just put the formula to calculate qt. So we run the experiment for 10 to 120 minutes. Our initial concentration was 30 milliamp per liter or 30 ppm, where we calculated the ct value at different time intervals from 10 to 120 minutes with 10 minutes interval each. According to formula, our x-axis will be ln t. So we will calculate ln t first and then we will calculate the y value t value. So for calculating ln t, we will take ln of time value, ln of this. So this is our ln t value. Now we will calculate. Now we will put the formula for qt is equal to initial concentration minus final concentration multiplied by volume divided by mass. As in our case, I already told that our mass and volume was same, so we can just put multiplied it with 1, or we can just only do c naught minus ct. That will give us qt value. So this is our qt value. In the formula, this B11, these values shall be used throughout the formula. So we will log these values by putting $sign before and after. And then double click this one, the formula will be copied. So over here, we will plot ln t versus qt. Go to the insert. In the charts, select the scattered one. And this is our now we will make a trend line, linear trend line of this and display the equation and r square value. Because from this equation we will calculate the slope and intercept. So our slope over here is 6.59
0.76, while our intercept is minus 14.347. So, according to the formula, our slope is equal to 1 over beta, while beta will be equal to 1 over slope. So this will be equal to 1 divided by the slope value. Okay. Now from the intercept we know that, from the equation we know that intercept is equal to 1 over beta ln alpha beta. Our intercept is equal to 1 over beta ln alpha beta. If this beta value comes over here with the intercept, so this will be equal to intercept into beta is equal to ln alpha beta. Then this equation we can manipulate this equation, and intercept into beta will be equal to ln alpha plus ln beta. As we already have beta value, so it will be equal to ln alpha plus ln beta. And then our ln alpha will be equal to intercept